Welcome back, everybody. I'm happy to have you all here. In a second, we will start with the next presentation from Jelle Saint-Germain from Ad Rem. He will talk about the plastic in the plastic sorting solutions in Japan, especially, where they did a little project themselves, and it wasn't that little, because if you look at the numbers in Japan, they exported over 1 million tons of plastic to the rest of Asia, and the rest which stayed in Japan were mostly incinerated or landfilled. And yeah, while other Asian countries are limiting their waste imports, it becomes even more critical to recycle in Japan themselves. But I don't want to talk too much about it and give the word over to Jelle. He will be in the chat as well to answer your questions, so feel free to ask right out. Have fun, everybody, and we will give it over to him in a second when we get the screen loaded. And
good afternoon, or evening, or morning, depending on where you are following from. My name is Jelle Saint-Germain. It's a Dutch first name and a French second name, which causes the necessary confusion a lot of the time, so don't worry about that. I speak Dutch as a first language, also speak French, but I would say I prefer English. Ich spreche auch ein bisschen Deutsch, selbstverständlich. Un poquito español, but still in the learning phase there. Anyway, it's the first time I'm giving a webinar, so if anything goes wrong, please excuse me in advance. There are some advantages and disadvantages with this way of presenting, of course. One of the advantages would be that people from all over the world can join without having to go to the same location. There are also some other hidden advantages for both parties. You, as members of the audience, you're free to leave at any time to get some coffee, or maybe even a beer or some wine. I won't judge because I can't. And on the other hand, if you are following this and you do not agree with anything I'm saying, please feel free to shout at your screen. It will be okay for me. Now, in all seriousness, I believe there should be a possibility at the end of the webinar to ask questions. So if you have any, please feel free to do so, and I will try to respond to them as adequately as possible. All right, so let's go. Before we get to the good stuff, I will show you two pictures to highlight the underlying issue we are trying to solve. The first picture is one of China. Fortunately, these are not mountains of plastic waste. Instead, you can see the karst formation of Gillen, which are a geological formation of soluble calcium-based rocks. Plastics, as you can see, are absent, and China would like to keep it that way. The second picture displays the city of Basel in Switzerland, which is home to 175,000 people, and at least to the people following this webinar, a very well-known convention. Of course, I'm not here to teach you geology or geography, but these two places have one thing in common. They are reshaping the global plastics recycling industries. In specific, I will focus on the case of Japan today. In 2018, Japan exported about 1 million tons of plastics overseas, down from almost 1.5 million tons before. I'm sure there should be some numbers on 2019 already available, but they are not available to me, unfortunately. In any case, this decline, of course, is due to China's import ban, and other Southeast Asian countries have taken a bit of the load, but as we all know, this will probably most likely turn out to be a temporary thing. Adding to that, plastic waste has now been classified as hazardous under the Basel Convention, effectively blocking its worldwide trade from January 2021 onwards. So that's in less than half a year. So these are two very good reasons for the Japanese government to stimulate domestic plastic recycling. So that's what they did. Japan uses what they call the 3R campaign, the reuse, reduce, reuse, and recycle. So in that order. In this 3R campaign, let's go to the next slide. That's how Planic got created. Planic is a joint venture company owned by Toyota Tsusho, Veolia Japan, and Kojima Sanyo, which is a producer for parts for the automobile industry. I'm sure the other two companies are well known. They all teamed up. They visited Galloo in Belgium, perhaps listened to some of my previous presentations on plastics recycling, and then decided to buy an Ad Rem plant. For those of you who don't know who Ad Rem or Galloo is, let me clear that up first. Ad Rem, which is short for Advanced Design of Recycling Machines, is the company I work for and was created as a joint venture between the Galloo Group and Valtech Group. Both of these groups are based in Belgium and are family owned, and in fact the owners of Valtech are the cousins of the owners of Galloo. However, their business is not the same. The Galloo Group is involved with the recycling of metals and plastics from shredder residues. They are one of the largest in Europe. And the Valtech Group is a group of no less than 13 engineering companies, all active in machine building for the environmental and textile industries. Ad Rem fits right in between. We are first and foremost an equipment manufacturer, but in doing so we can rely on the decades of experience from Galloo. Or long story short, Ad Rem develops and commercializes the machinery used at Galloo and sells it to other recycling companies worldwide. Here's a short company video that we included in this presentation, just to get you a little bit more familiar. This should work right now.
Our world is a beautiful place. It's where we work, where we play, where we dream. But what about our children? Every year, millions of tons of waste ends up in landfill. It damages the environment. Ad Rem changes that. We are leading the way in ensuring we leave a legacy for future generations. We specialize in the research, design, engineering, and construction of equipment for the recycling, mineral, and food processing industries. By making it possible to separate and recycle waste from cars, electronics, and household appliances, our technological innovation helps the world to recover more resources. Since 2008, Ad Rem has developed and optimized new ways of separating diverse waste streams and materials. As a joint venture, we are the result of a meeting of minds. The expertise of Galloo, Belgium's largest recycler, and the know-how of Valtech, an engineering and construction specialist closely connected to the recycling industry. Together, we have engineered a range of patented separation processes around one single goal: maximum waste recovery. Ad Rem machines prevent millions of tons of CO2 from entering the Earth's atmosphere every year. We are working to safeguard the future. Ad Rem.
All right, you may or may not have recognized someone in that video. Anyway, back to the interesting part. So Japan used to mainly incinerate or landfill their plastics or send them overseas. As a result, there is actually today little or no plastic recycling infrastructure installed in the country. Therefore, it quickly became apparent that Planic's plastic recycling program would have to entail the complete plastics recycling process from A to Z. So that's also what happened. On this slide, you can see a flowchart of their new plant. The input material will be a mixture of ASR, WePlastics, pallets and containers, as well as packaging materials from distribution centers and warehouses. So it's a very broad mix of mainly ASR and WePlastics. ASR, for people who don't know, is automotive shredder residue, and We is the electronic and electrical equipment. So these plastics will undergo a pre-treatment, after which they will be separated by density and then further separated into 4 kinds of output plastics: PE, PP, PS and ABS. The PS and ABS, so the polystyrenes, are sold as flakes, while the PE and PP, the polyolefins, will be compounded, re-extruded and pelletized on site to eventually serve as a new resource. Let's zoom in on the different parts of the plant. Also, to clarify, the density separation is really where the core technology of Ad Rem comes into play, but the whole line up to compounding of the PEPP will be built by us. In the pre-treatment, the input material is cleared of any ferrous metals by an overbelt magnet before going into the shredder. Here the material will be shredded to a maximum size of 60 millimeters. The shredded material continues over a flip flow screen to sieve off the fines because they could interfere with the medium during the wet separation further downstream, which I will explain in a minute. The same goes for the light materials such as textiles and foams, because they could soak up the medium, which is why they are removed using a wind sifter. So in a wind sifter, light and foamy material goes up with an airflow, while the heavier material falls down gravitationally. And this heavier material, this fraction, is the plastic mix that's ready to undergo the density separation process. Now, to understand our density separation process, we can watch another short video. This is an explainer video that we made a few weeks ago. So this will be the premiere in this webinar. Okay, so this should be it.
Every year, millions of tons of plastics end up in landfills. This not only damages the environment, but also wastes a valuable commodity. Ad Rem are specialists in building the machines that enable separation and recycling from cars, electronics, and household appliances. Our innovative, patented flotation processes are specifically engineered to maximize recovery of plastics from shredder waste. This is how it works. The input to the process can be plastic mix from ASR, WE, or other rigid plastics. The washed material is placed in the plastic flotation tank filled with what we call a medium. That doesn't mean it can read your mind. Medium is a liquid consisting of water with an added substance to make it heavier. With a density of 1.2 kilograms per liter, 20% heavier than water, the medium ensures good plastics float, while the chlorinated and brominated plastics sink, together with any remaining metal residue. The good plastics float to one side of the tank, with the harmful and currently non-recyclable chlorinated and brominated plastics screwed out at the other side. As a patented technology, our medium is a suspension and not a solution, which means it can be recovered and reused. pH neutral and harmless for the environment, it is also cost-effective, supporting the profitability of recycling companies worldwide. In a second separation tank with a water density of precisely 1.09 kilograms per liter, recyclable plastics float while RDF plastics sink. We send the non-recyclable RDF plastics onto a waste-to-energy facility where they are incinerated to recover the thermal value. In a third separation tank with a water density of 1 kilogram per liter, PE/PP floats and PS, ABS sinks. The end products are then re-extruded and granulated, transforming them into a resource for new products. At the end of the separation process, we have chlorinated and brominated plastics, waste-to-energy plastics, a mix of PE and PP, and a mix of PS and ABS. The Ad Rem plastic separation process makes it possible to recover and recycle up to 70% of plastics that previously went to landfill, saving millions of tons of CO2 output while creating significant value for the customer. Together, we are working towards a sustainable future. Ad Rem.
Right, so let's recap. In the case of Planic in Japan, there is no separation on 1.20 specific gravity. The amount of plastics that could be useful for waste to energy applications is quite low, actually, which this has been found this way. So there we skip this step. So in their density separation process, the plastic mix is first sent through a separator at 1.09 specific gravity. So that means 1 liter of medium weighs 1.09 kilograms. At this density, the plastics are separated in two fractions. The recyclable plastics containing the PE, PP, PS and ABS will float, while the non-recyclable plastics containing the chlorinated plastics, the brominated plastics, as well as residual metals and any other non-recyclable plastics will sink. Some of these non-recyclable plastics are, for example, polycarbonates or PMMA. So the floats are pushed out at the top of the tank of the separator, and the sinks are screwed from the bottom to the opposite end of the tank. Right. The correct density is obtained by adding a pH-neutral agent to water. The use of this agent in the flotation process is actually patented by Galloo Plastics. Of course, we have the license to distribute this technology. As opposed to the traditional use of salt, this agent does not dissolve in water but remains in suspension, which enables us to recover and reuse it. It is a cheap substance, about €80 per ton, depending on of course, which grade you buy and where you buy it. And it does not interfere with electrostatic separation further downstream. Other examples of flotation systems that use salt often use salts that cause a disturbance to the mechanism, the charging mechanism of the electrostatic separation. Of course, there is some specific salts that you can use to avoid this problem, but then these become very expensive, up to 10 times more expensive than the agent we are using. In the case of Planic, we actually do 2 separations on 1.09 specific gravity. The bulk of the sinks are captured in the first separation, after which trapped pollution is liberated from the floats and separated off again in a second separation. In the next step, we separate the polyolefins from the polystyrenes in a separator running on water. The PEPP, so polyethylene, polypropylene, will float, and the PS-ABS is heavier and will sink, polystyrene and acrylonitrile butadiene styrene. Obviously, in this case, there is no agent added to the water, but of course, the difficulty in this step is, or in this separator, is to keep the water clean, so its density remains at a steady and constant level of 1 specific gravity. The PS-ABS mix continues to an electrostatic separation system in which the materials are selectively charged using a high voltage field of around 35,000 volts. As a result of this charge, the conductive particles are susceptible to a magnetic force that is applied at the end of a conveyor belt. The charged particles will be attracted towards an electrode with reversed polarity and can be separated from the uncharged particles. By adjusting the splitters, the product purities can be fine-tuned much in the same way as with eddy current systems. The charging of the particles is critical to the process, which is where the compatibility of different kinds of medium, flotation media, is really important. The PE-PP mix will be further separated using the technology developed in-house by Galloo Plastics. The end result of that is that 2 different types of plastics will be ready for compounding, pelletizing and re-extruding, which will be done on site. The PS and ABS can also be turned into new pellets, but in the case of Planic, this will not be done on site. Planic's new plant will process around 40,000 tons of plastic material per year. It will be located in Omaezaki City in the Shizuoka Prefecture and is set to be fully operational by 2022. So next year we are now in the designing phase of the project. Next year we will start with the installation, and at the end of the project the fully operational plant will be ready in 2022. This will be a building. It's about 120 by 30 meters, I think, that will be filled with this equipment. After 20 years of in-house plastic recycling at Galloo and Ad Rem already having built many other plastic processing facilities around Europe, for example, at AO Recycling in the UK, we finished the plant last year to process fridges. This was also with the same setup. There we have the 1.09 and then the 1.0 density steps to separate the different plastic fractions. And then the PS-ABS mix continues to a HAMOS electrostatic separation system. This plant has already been fully operational now for almost a year, I think. We have several, let's say, plants that gave us a lot of experience for this project in Japan. So Planic's factory in Japan will now further reinforce the maturity of the plastic recycling industries on a more global scale. As climate change and plastic pollution become the focus of increasing public attention, consumers are starting to demand more sustainable corporate practices. This consumer demand can now be met as new investments are backed by qualified processes. With their new plastic recycling facility, the Toyota Group, together with Veolia, they will be among the pioneers of this global transition to sustainability. That's a mouthful. These rather philosophical words mark the end of this webinar. I hope it was interesting and you were able to enjoy it. At this point, I would usually invite you or encourage you to come taste some delicious Belgian chocolates at our booth. But unfortunately, in this case, I'm afraid a picture will have to do. So here it is. Don't get too hungry. If you ever do meet me at some in a more physical form at some other exhibition or event, which I hope will be sooner rather than later, don't hesitate to grab some chocolates because now I owe you, of course. Thanks for watching and hopefully see you soon. Bye-bye.
Well, thank you so much, Jelle, and for the chocolate invitation as well. I will come back to that whenever I come to Belgium and visit you. Totally. Thank all of you for being here, for viewing that webinar with Jelle Saint-Germain from Ad Rem. If you have any questions, you can ask them over the chat, and Jelle will answer them for you. Maybe we can post his mail address to the chat as well, so you can get in contact with him as well, especially if you ever go to Belgium and want to grab these chocolates, or maybe a whole recycling plant as well. So yeah, thank you all for being here. We will leave the webinar open for a few more minutes for anybody who got any questions. You can just ask them through the chat, but yeah, thank you so much for being here there. And yeah, I will get out, and yeah, Jelle will be there through the chat to answer your questions. For all the others, I would be happy to see you again at any of our booths, at one of the next conferences, or maybe in our LinkedIn group of the EREC, where you will be able to connect with the other attendants and the speakers as well. Thank you so much. Have a nice lunch break. See you soon. Bye.